Hello, I'm Peter Moskowitz with Confluent, here to tell you about the HTTP Sync v2 connector. Kafka is a powerful platform for streaming data. Getting that data where it needs to go is just as important. That's where Kafka Connect helps. Instead of building and maintaining custom integration code, connectors allow data to flow smoothly between Kafka and external systems with minimal setup. This is what the HTTP Sync v2 connector is designed for, reliably delivering real-time Kafka messages to any API that accepts HTTP requests. This connector eliminates the need for custom scripts or ad hoc solutions. It natively integrates with APIs, handling authentication, retries, and message transformations automatically. Whether you're updating a SaaS application, triggering events in an external system, or syncing data with a third-party service, this connector provides a direct path from Kafka to HTTP-based applications. One of its key advantages is flexibility. It supports GET, POST, PUT, and PATCH request methods, making it useful for both event-driven updates and full data synchronization. The delete method is also supported as long as the key is non-null and the value is null. Plus, it supports OpenAPI 3.0, meaning you can describe the API endpoints in a structured way, making setup smoother and reducing errors. This file is often referred to as the Swagger file. Authentication is built in with support for basic auth, bearer tokens, and Auth 2.0 client credentials, ensuring compatibility with modern APIs. Client-side field-level encryption, CSFLE, protects sensitive data before it leaves Kafka. And you define encryption on a field-by-field basis, so it's super fine-grained. Check out my video series if you want to learn more about CSFLE. Reliability is another critical feature. The connector guarantees at least once delivery, so every record in Kafka is sent to the API, even if there's a temporary failure. If an API is rate-limited or temporarily unavailable, the connector automatically retries based on configurable settings. For those who need to modify or filter data before sending it, the connector supports single message transforms, SMTs. This allows lightweight modifications such as renaming fields or dropping unnecessary records before they are sent. If you need more advanced processing, tools like Flink can help. The HTTP Sync v2 connector also supports path variables and template variables. Path variables allow dynamic URL paths based on Kafka record values. This is useful when routing data to different API endpoints based on dynamically changing values. Using template variables in Kafka connectors allows for dynamic configuration of connector settings, enabling flexibility by substituting values like topic names at runtime. This makes connectors more adaptable to different environments or datasets without requiring manual configuration changes for each deployment. A major upgrade in v2 is the ability to handle multiple API paths within a single connector. Up to 15 different destinations can be configured, making it easier to manage complex integrations without running separate connectors for each endpoint. Let's break down how this works. Kafka Connect operates using tasks, which are independent workers that process data in parallel. Each task is responsible for retrieving records from Kafka, applying any necessary transformations, and sending them to the correct API path. This enables the connector to scale efficiently, handling large volumes of data across multiple destinations. By default, each path has a dedicated task, but you can increase the number of tasks to meet your scaling needs. And an important note, if you are currently using the HTTP Sync v1 connector, it's time to start planning your migration. v1 will eventually be deprecated, and v2 provides a more robust and flexible solution. Let's see it in action with a demo. I'm logged in to Confluent Cloud. In my environment, I have another connector set up, an HTTP source v2 connector that's reading the data and publishing it to a topic. Our job will be to consume the messages from that topic and send them to an HTTP service. In our example, the HTTP service persists the data to Airtable. So let's start by creating our sync connector. We'll call our connector HTTP Airtable Sync Connector. The Swagger file describing our service is located on my machine, so I'll go ahead and upload it. We will authenticate with a fresh pair of key and secret, As I create them, they are automatically downloaded to my machine for later use. The authentication screen shows the URL endpoint of my service. This is where I can also pick my HTTP service authentication options. This service doesn't require authentication, so no work required here. We can also optionally customize SSL by uploading our key store and trust store. We'll skip this step. Under paths, our endpoint using the post method is shown. Let's select it. Under configuration, we have the option to create a new topic that will consume the messages from, or use an existing one. Since we already have a topic that holds the messages we want to consume, we'll simply select it. Credit card topic 1. We'll skip request config and dive into settings. Here you have a broad range of options available to you. Under advanced configuration, you find client-side field level encryption, CSFLE. For specific configuration options, check the documentation. Now let's test our service. We'll send a JSON object to our HTTP endpoint, and if all goes well, the data we pass will be saved to Airtable. My table is open in another browser window, and it's empty at the moment. Here you can see the fields. These are the fields of a credit card transaction. They align with the values in our topic: first name, last name, credit card number, CVC, expiration date, and so on. I paste a test record into the dialog and hit the test button. At this point, the record is submitted through HTTP to our service, which in turn does its thing. In our case, it saves it to this Airtable. Pretty cool, isn't it? Let's hop back to Confluent Cloud. We will skip single message transforms, but if you'd like to see them in action, you can check out my video about the HTTP source v2 connector. The HTTP sync v2 connector allocates one task per path by default, which is the minimum. But if your load is high, you can add additional tasks to improve performance. Notice that the number of tasks is used to calculate the price at the bottom of the page. Lastly, you can review your settings in case you want to create scripts or use the APIs to automate your environment. You can also easily access the JSON configuration of your connector. As your connector is starting up, let's navigate to our topic and check on our Airtable at the same time. You can see that as a new consumer, our connector reads the topic from the beginning and the rows in our Airtable are filling up. You may notice that the credit card numbers are masked for the more recent records. Eventually, our connector catches up to the last message, and as the messages are arriving to the topic, they are sent to Airtable as well. Here we can see that the last record on the topic is JSON Friesen, and our Airtable is in perfect sync. And that's it! We've successfully configured the HTTP Sync v2 connector in Confluent Cloud to save data to an external sync over HTTP. Now it's your turn to give it a try. What are you going to build?